Hello guys, welcome back to the channel. So today we'll be solving some past questions relating to differentiation. So let's start with our first example. So with example 1, we are given two functions, that's u and v, and we have to find the rate of change of the product of these two functions. So now the first thing that should come into mind is the product rule, because we have two functions multiplying, that's u times v, and we're being asked to find the rate of change of the product of these two functions. So now let's move on to solve it. So we have u multiplying v. Then by the product rule, the rate of change of the products of u and v is given as, so now the rule says that you keep one function. So now here let's keep u and differentiate v. So that will be the v dx. Then we add it to, then we are going to keep v in this case. Then we differentiate u with respect to x. So this is the product rule. So that's the rate of change of the product of these two functions, u and v, is given as u multiplying the v on the x plus v multiplying the u on the x. So now let's compare if our answer will match the options given. Now let's compare if our answer will match one of the options given above. So as we can see, our answer will match option C. So that's option C is our answer. So in this case, our answer is C. Now with question 2, we have a function x squared minus 4xy plus y squared is equal to 4. And we have to find the rate of change of y with respect to x. So here we are being asked to find the rate of change of this given function. Alright, so now let's differentiate this given function. So here we should know that we are going to use implicit differentiation to solve this given question, because here y is not being expressed explicitly in terms of x, right? So now we are going to use implicit. So now we should know that when we get to this term, we are going to use the product rule to differentiate x multiplying y. So let's start with the first term. So you have to differentiate x squared with respect to x. So that will give us 2x. So with the second term, let's factorize minus 4 out. And so here we have to differentiate the product of x and y. And by the product rule, we are going to keep one function, then we differentiate the other, then vice versa, right? So we are going to have, so here let's keep x. So we are going to keep x, then we differentiate y with respect to x. That will give us the y dx plus, then we are going to keep y, then we differentiate x with respect to x, and that will give us 1. Then plus, now let's differentiate. Now let's differentiate y squared. That's going to give us 2y dy dx is equal to, now when you differentiate a constant, we are going to get 0. So that will be 0. Now let's expand. So we're going to have 2x minus 4x dy dx minus 4y plus 2y dy dx is equal to 0. So here let's group like terms. So those terms with dy dx should stand on one side, and the terms without dy dx should go on the other side. So we are going to have 2y dy dx minus 4x dy dx is equal to 4y minus 2x. Now let's factorize dy dx out on the left hand side. That will give us dy dx into bracket 2y minus 4x is equal to 4y minus 2x. So our goal is to make dy dx the subject, so we divide by 2y minus 4x. So our answer will be dy dx is equal to 4y minus 2x divided by 2y minus 4x. So this is the rate of change of y with respect to x. So let's go to the options and see if our answer is correct. So now, based on the options, we had our answer to be 4y minus 2x on 2y minus 4x. So our answer is option C. With our third question, we have to evaluate the integral 5x minus 2 all raised to an exponent of 6 dx. So this integral is an indefinite integral. It's indefinite because we don't have the range of integration here, right? So this is an indefinite integral. So now let's solve. So here we are going to use integration by substitution. So we are going to let this guy be equal to, say, u. That's u is equal to 5x minus 2. Then we just have to integrate. So that's quite easy. So now let's integrate it. So using integration by substitution, we let u to be equal to 5x minus 2. All that we want to do is that we want to transform from the x domain onto the u domain, right? So which implies that we should change the x, because the x is in the x domain, right? So we should change from the x to the u, and we should change all these guys from x to u. So that's all that we have to do. So our integral will now become integral. Now note that this guy is now what, u. So we are going to have u exponent 6 dx, but we still have the x here. Now our goal is to transform from the x domain onto the u domain. So what should we do? We should find the u from this relation, right? So we have u to be equal to 5x minus 2. Then what will be the u? Then the u will be 5 dx. Now let's make the x the subject. So the x will be equal to the u on 5. Now we now have an expression for the x in terms of the u. That's this guy. So now we are going to write this guy in here, because this is just the x, right? The x is equal to the u on 5. So our integral will become integral of u exponent 6. Now what's the x? The x is now the u on 5. So here we have our integral in terms of u, so we can easily integrate our function. So we can factorize 1 over 5 out to get u exponent 6 the u. Now let's integrate this guy. So we are going to use the power rule to integrate. So you add 1 to the exponent, and then you divide by the new exponent. So you're going to have 1 over 5 u exponent 7 divided by 7 plus an unknown constant c. C because this is an indefinite integral. So now let's do our multiplication. So we are going to have 1 over 35 u exponent 7 plus c. But what's u? U is equal to what? 5x minus 2, implying that our answer will be given as 1 over 35 5x minus 2 all exponent 7 plus c. So this is our integral. So let's compare our answer to the options given above. So our answer is option A. With question 4, we have to find the second derivative of the given function x plus xy plus y is equal to 2. So with this question, we can use either the implicit differentiation or the quotient rule. So here I'll prefer to use the implicit differentiation. So now let's differentiate x with respect to x. That will give us 1. Now the second term, we have the product of two functions, so you're going to apply the product rule. So you keep x, differentiate y with respect to x, that will give you dy dx, plus keep y, differentiate x with respect to x, that will give you 1, plus differentiate y with respect to x, that will give you x. Now differentiate a constant with respect to x will give you 0. So let's make dy dx the subject. So dy dx plus x dy dx is equal to minus y minus 1. Factorize dy dx, we are going to have 1 plus x multiplying dy dx is equal to minus y minus 1. Making dy dx the subject gives minus y minus 1 on 1 plus x. So let's call this equation, say, equation 1. And let's call this guy, say, equation A. So now let's differentiate A again. Now the first term is 1, so that will go to 0. Now with the second term, we have the product of two functions, that's x and dy dx. So we apply the product rule again. So you keep one, you differentiate the other, plus you invert. Okay. So we are going to have, now let's keep x, differentiate dy dx with respect to x, that will give you the squared y on the x, plus now we now keep dy dx, then we differentiate x with respect to x, that will give us 1, plus now differentiate y with respect to x will give you dy dx, then plus differentiate dy dx with respect to x will give you the squared y on the x squared. Differentiate 0 with respect to x will give you 0 because 0 is a constant. Alright, so now here let's make the squared y on the x squared the subjects. So we are going to group like terms, right? So we are going to have x the squared y on the x squared plus the squared y on the x squared is equal to minus dy dx minus dy dx. So now these guys are like terms, so we can add them to get minus 2 dy dx. So here on the left hand side we can factorize the squared y dx squared out. So we are going to have x plus 1. Good. Now note that from equation 1 we have dy dx giving us minus y minus 1 on 1 plus x. So we're going to substitute this guy in here. Right. So we are going to have minus 2. What's dy dx? From equation 1 we have dy dx as minus y minus 1 divided by 1 plus x. Right. Then let's simplify. So we're going to have minus 2 times minus y will give you, so we're going to have minus 2 times minus y will give you 2y, and plus 2 divided by 1 plus x is equal to the squared y on the x squared x plus 1. So here we can factorize 2 out, that's y plus 1 plus x. Now we need to make the squared y on the x squared the subject, so what should we do? We divide by x plus 1, that's the coefficient attached to the squared y on the x squared. So dividing through by x plus 1 gives 2y plus 1 x plus 1 divided by x plus 1. So we are going to have 2y plus 1 on 1 plus x multiplying 1x plus 1. So this will give us 2y plus 1 multiplying 1 plus x all squared. That's the squared y on the x squared. So this is our answer. Now let's compare our answer to the options above. So based on our answer, the correct option is option B. Alright, so now let's solve our last question for the day. So we are given f of 4 to be equal to 2, g of 4 to be equal to 5, and g prime of 4 to be equal to minus 3. And we are being asked to find h prime of 4. Now we are very lucky that, so here we've been given h of x to be equal to f of x on f of x plus g of x. Right, so here we have to find the derivative of h at the point 4. So here h is being given as a fraction, right? So for us to find the rate of change, we should apply the quotient rule. So now let's apply the quotient rule. The quotient rule says that if we have a function, say u of x divided by v of x, then the rate of change of this function is giving us you keep v, then you differentiate u, minus you keep u, then you differentiate v, all divided by v squared. So this is how we are going to apply the quotient rule. So here f of x is your u, that's the numerator, and this entire function is your v, that's the denominator. So now let's apply the quotient rule. Then what will be h prime of x? H prime of x will be giving us, so keep v, that's f of x plus g of x, then differentiate u, that will be f prime of x, minus keep u, that's f of x, differentiate v, so that will be f prime of x plus g prime of x. So here we are going to use the sum rule, right? So we just differentiate each time. So you differentiate f, then you differentiate g, then all divided by v squared. And what's v? V is giving us f of x plus g of x all squared. So that's it. Now we can simplify further. So let's simplify further a bit. So we are going to have f prime multiplying this guy, so that will be f of s, f prime of x plus g of s, f prime of x. So same to the other term, so that will give us minus f of x, f prime of x, minus f of x, g prime of x, all divided by f of x plus g of x all squared. So as we can see, these two guys will cancel out, this will cancel out, so we are going to be left with g of x, f prime of x, minus f of x, g prime of x, all divided by f of x plus g of x all squared. So from the question, we have f of 4 to be given as 2, g of 4 to be given as 5, g prime of 4 to be given as minus 3, and f prime of 4 to be given as 6. So our goal is to find h prime of 4. So h prime of 4 will be giving us g of 4 f prime of 4 minus f of 4 g prime of 4 divided by g of 4 plus f of 4 all squared. Now what's g of 4? That's 5. What's f prime of 4? That's 6. Minus what's f of 4? That's 2. What's g prime of 4? That's minus 3. All divided by g of 4 is 5 plus f of 4 is 2 all squared. So you're going to have 30 plus 6 on 7 squared. That will be 36 on 49. Hence f prime of 4 is giving us 36 on 49. Alright, so that's the end of today's video. Please make sure to subscribe and see you in the next video. Bye.